Hi everyone, today we're going to continue talking about systems of equations. So far we have solved systems of equations through graphing and also through substitution. Today we are going to solve using elimination. So how can we solve through elimination? Well, one thing that's kind of cool about algebraic expressions is we can add them and subtract them. So we're going to go with adding these two equations together. If I take 3x and I add 9x, I get 12x. If I take 3y plus a negative 3y, these cancel out. Then I have negative 12 plus 24. I get a positive 12. Now I can divide both sides by 12. And I get x equals 1. So now I know half of my solution to my linear system. X will be 1. So now I can plug in 1 to either one of these equations. It doesn't matter which one. I kind of like this one for some reason, so I'll plug it in there. And I'm saying x is 1 now, so I'll do 3 times 1 plus 3y equals negative 12. Well, 3 times 1 is 3 plus 3y equals negative 12. I'm at a two-step equation. I can just subtract 3 from both sides. I get 3y equals negative 15. And my last step will be to divide both sides by 3. And y will equal negative 5. So 1, negative 5 should be my solution to this system. In other words, if I plug 1 in for x and negative 5 in for y, both of these will work. Well, I know the first one will because I just used that to solve for y. Let's go to the original equation. 9 times 1. This method is really good when you have equations that are written in standard form, like these are. Minus 3 times negative 5 equals 24. I didn't need to rewrite either equation. They were already in a nice form where they canceled out. 9 times 1 is 9. Negative 3 times 5 is positive 15. I think I said negative 3 times 5. I should have said negative 3 times negative 5. It's positive 15. And does 9 plus 15 equal 24? I could go ahead and write 24 equals 24, but I know that is correct. So it worked. So it works for both of them. Pretty cool, huh? So your goal is to be able to add them so that one of your variables is eliminated so that it cancels out. And if I graph these, you'll see that they intersect right here at 1, negative 5. Okay, let's solve this by elimination. Now you'll notice that adding them, neither will cancel. But I could multiply this bottom equation by -1. Multiply everything by -1. So that I get a -6x. I'm going to write it up here, even though I prefer to write in a separate line, but space is always an issue when I'm working on my slideshow. -1 times 7y makes it a positive 7y. And then I have -20 times -1, and I get a positive 20. Now I can add these two equations. 6x, -6x, that cancels out. 5y plus 7y, I'm going to write it down here, is 12y. 4 plus 20 is 24. The nice thing about this, I usually end up with a nice one-step equation at the end. Divide both sides by 12. I might need to do some manipulation in the middle, but at the end I'll end up with a one-step equation. Y equals 2. So in my solution, I know y will be 2. So now let's go back to either one. Again, I could do either one. I'll do the first one, because why not? 6x plus 5 times 2, because I'm substituting 2 for the y, because that's what I know what y is, equals 4. 2 times 5 is 10. 6x plus 10 equals 4. Let's subtract 10 from both sides. And my 6x will equal -6. Divide by 6. Divide by 6. And I will get my x equals -1. So the solution to this system of equations is x is -1, y is 2. I could plug it in. 6 times -1 is -6. 7 times, -7 times 2 is -14. -6 minus 14 does in fact equal -20. So it works. Let's try another one. 4x plus 3y equals -13. Well, if I look here, nothing cancels out. So that's kind of a bummer. And I can't like multiply this by like a -1 to make it cancel out still. So I look and I go, what could I cancel out? And notice I have a positive 3y here and I have a negative 2y. Can you think of something that I could multiply each of these by so that these cancel out? I could multiply my top equation by 2. And I could multiply my bottom equation by 3. We'll see what happens. End up with 8x. And 2 times 3 is 6y, so plus 6y. Equals, -13 times 2 is -26. I usually look for one where I have a positive and a negative, and I just multiply it by the opposite coefficient. So this one I multiply by this coefficient. This one I multiply by this coefficient. So the 3 times the 2, the 2 times the 3. And since one was negative and one was positive, they will cancel out. 3 times 5x, 15x. 3 times negative 2y, negative 6y. You see how those are going to cancel out now. And 3 times 24, 72 hours and 3 days. 3 times 24 is 72. Now I can add 8 plus 15 is 23x. My y's cancel out, 6y and negative 6y. 72 and negative 26 is 46. Last step, I'm going to divide both sides by 23. I'll find that x equals 2. So now I have to plug in 2 for x to solve for y. Now I rewrote my equations here, but I don't usually use those to solve for my y value. I'm going to go back to my original equations, and I could use either one. Let's do the second one. 5 times 2, because I'm saying x is 2, minus 2y equals 24. Now I've done quite a bit of manipulation on this one, so it doesn't hurt to verify on both equations to make sure it works when you're done. 10 minus 2y equals 24. Subtract 10 from both sides. I get negative 2y. Don't forget you have that minus in front of the 2y. Negative 2y equals 14. Let's divide both sides by negative 2. And y will equal negative 7. So let's just do a quick check to make sure that 2, negative 7. We know it works for this equation because I just solved it to get that. So let's go back up here. 4 times 2 is 8. 3 times negative 7 is negative 21. Is 8 minus 21 equal to negative 13? And it is. So that is a solution to this equation, and we know it's also a solution to this equation. So that's the solution to my system. Okay, let's solve another one. Again, in this case, I don't have a positive and a negative. I don't have anything that cancels out, so it's kind of annoying. It's like, what can I do? I could decide which I want to cancel out, my x or my y. It doesn't really matter. I could multiply this equation by 5 and this one by negative 3, and then my 15x and negative 15x would cancel out. I could multiply this equation by 6 and this one by negative 4. Again, it would cancel out. I could look for at least common multiple and multiply this one by 3 and this one by negative 2, and then I would have a 12y and a negative 12y. Lots of options. Just to keep things more simple, I'm going to use my 3 and my 5. So I'm going to multiply this by 5 and this by negative 3. Is that what I would probably do? I probably would have gone with the multiplying this by 3 and this by negative 2, I'll be honest. I'm going to multiply this by 5, oops, because I like to keep my numbers smaller if possible. But I don't want to throw too many things at you at once. Multiply this by negative 3. Five times 3x is 15x. 5 times 4y is 20y. And 6 times 5 is 30. Negative 3 times 5x, negative 15x. Negative 3 times 6y is negative 18y. And 4 times negative 3 is negative 12. Now let's add these two equations. You'll see my x's cancel out just as I had hoped. 15x and negative 15x is 0, so that's gone. 20y, negative 18y is 2y. And 30 minus 12, or 30 plus negative 12, is 18. Let's divide both sides by 2. And I get y equals 9. Now again, I can go to either equation and solve for x. Let's go to the top one this time. 3x plus 4 times 9, I said y is 9, equals 6. 4 times 9 is 36. So 3x plus 36 must equal 6. Subtract 36 from both sides. Three x equals negative 30. I don't know why I randomly draw lines. I just do sometimes if I feel like I'm getting too much information, I think. Divide both sides by 3. My x will be negative 10. This is where having messy handwriting can sometimes hurt you. Just want to make sure you know up here, this is a y that's a 9. So my order pair is 10, 9. So let's check it. I used this one already, so let's go to this equation. 5 times 10 is 50. Oops, I messed up. It's negative 10. I was like, that didn't make sense. It's negative 50. 6 times 9 is 54. Negative 50 plus 54 currently does equal 4. See, it's checking it's where I catch my mistakes, because if I suddenly had 50 plus 54, that doesn't equal 4. So that's how I caught that I should have a negative 10 there. Okay, I have a word problem here. I'm running a concession stand at St. Paul Saints baseball game. I'm selling hot dogs and sodas. Now let's look at this. Each hot dog costs $5. Each soda costs $2. I sold 87 hot dogs and sodas and collected $267. I have to know how much of each I sold. So I'm going to call my hot dogs H and my sodas Y. So I know I sold a total of my X plus my Y, my hot dogs and my sodas together. I sold 87. So my hot dogs and my sodas equal 87. Then I have $5 hot dogs, so $5 times my number of hot dogs sold, and $2 times the number of sodas I sold, gave me a total of $267. So what's the easiest way to cancel something out here? Well, I think multiplying this top equation by -2. I could just as easily multiply it by -5, but 2 is easier to multiply by. I'm going to multiply this top equation by -2. -2 times x, -2x. -2 times y is -2y. -2 times 87 is 174, I believe. Negative. So now what am I left with? 5x minus 2x is 3x. My y's cancel out. 267 minus 174. Well, 7 minus 4 is 3. Simplify this. 16 minus 7 is 9. And 1 minus 1 is 0. So 93. Divide both sides by 3. And I have x, or my number of hot dogs, being 31. Because I sold 31 hot dogs. Now to solve for y, it's easiest to use this top equation because I know my 31, my hot dogs, plus my sodas equals 87. So just subtract 31 from both sides, and I will have my number of sodas being 56. So that will be 56 sodas. Oops, I lost my video. 56. So 56 sodas, 31 hot dogs, for a total of $267. So just quick steps to get your opposites. You want to get opposites in x or y's. You may need to multiply one or both equations by a number to get opposites. Add the equations. Substitute the solution into one of the original equations to solve for the other variable. That's it. Have a good day.